So let's quickly create a proxy of a tree that we can scatter all around. I'll do that with a line. Let's say it goes all the way up to 20 meters of height. Let's zoom on it. Let's resample. The reason why I'm going to resample is because it's going to generate a curve view attribute on the points. Basically, maybe 2. That's fine. Okay. And as I was saying, the distance attribute not relevant, but the curve view attribute is good. And we can then use a point wrangle to control the width attribute with a ramp. So let's create a width attribute, which is going to be equal to a ramp channel called width ramp based on the curve view of each point. And we're going to multiply this by another channel that's going to be the maximum width. And that's it. So this is going to give us a ramp where we can control the maximum width. Let's start with 6 or 5. And set width. And we'll create a polywire which reads that attribute. You can even use the $sign expression. And as you can see, it's reading it. Now we want this the other way around. And maybe at a, let's set this interpolation to get more ROM. Maybe not. Let's leave it at linear and let's just kind of something like this. Let's give it a few more divisions here. Let's add a normal and lower this to 15, maybe 20. Let's give it a green color, might help. And we have a tree proxy. If you want to play with it a bit more, just you can add as many points as you want and you can create kind of a weird shapes. Not going to spend too much time on this, but maybe kind of just create a nice gradient here. And so we have our tree. Let's just create a output null for this. So out tree proxy. Select all of these, Alt A, and let's just align them. And now let's go back to our terrain and let's see how we can go ahead and scatter this. So let's create a height field scatter. We're going to be scattering based on a mask that's coming from there as well. The mask layer is going to be the trees. Let's go ahead and do by courage. The tag name, we can leave it like this, or we can use it tree. It's fine. Let's see how this looks. That might take a while. The coverage is a bit high. Not sure about the arrow radius. We need to pull this up. Let's have it match the maximum width that we have here. So the maximum width, let's copy this parameter and connect it here to the arrow radius. And let's say base relative reference. We should probably divide this by 2 to be more accurate. And let's put in the trees, see how this looks. And let's adjust our scattering. So maybe not divided by 2, probably As this is fine. Yeah. Now here on the scatter, we've dealt with this before on the previous tutorial, but let's go ahead and refresh some of these concepts. I think we can rearrange this better. Maybe put this here, put the visualize on the other node, and let's put this higher. So here on the height field, the first thing is, as you can see right now, the normal is being, it's it's automatically aligning the instances to the normal of the surface, and we really don't want that to happen. So here on match normals with terrain, let's turn that off, and we can randomize up a few degrees to have them kind of be slightly disaligned. And here on the randomize yaw, let's put it at 180 so they have random rotations. Not really noticeable because this is a radial symmetry model of a tree or proxy. And other than that, we can kind of, the random values here seem to be giving us a good result. So I'll probably leave it. I think this could work well. If you want to have a controller for the scale of the trees, we can add it here. Let's say we add a transform. Say we want the trees to be overall slightly bigger. We can set or control scale. And we can use this uniform scale to control that. So if we increase the trees, they're going to get bigger, smaller. But we should have this also affect the scattering effect. So we should copy this parameter. I'm going to put it back to 1. And here on the height field scatter, we should take not only into account the width, but also that. So we're going to multiply this by that uniform scale, base relative reference. And now it takes into account. So if we decide that the trees are bigger, the height field scatter will know that the outer radius also needs to be bigger. So let's say control scale, and let's say I want them to be twice as big. We'll have much less trees scattered. And if we want to have them be smaller, we'll have a lot more trees scattered. So this is the proper adjustment. Okay, I'll leave it at 1 for now. Seems to be at a good scale. I like the randomization that we have, and you can also play with some blur on this mask. Let's say we want to add a height field blur. I'm going to connect it here. And the blur that I want to be applied to the trees, let's say it's a blur radius of 16. Let's have a look at what this is doing. We can just connect this height field visualize here. Okay, so it's blurring out. So it's not as defined as it was before. Okay, if we disable this, you'll see the difference. And you can also see the effect that this has on the scattering pattern. Okay, this is a more sharp pattern, and this is kind of a bit more of a, the shapes aren't as defined. Maybe it's probably clearer from top view. Okay, but we should be able to see that the margins are slightly different. It's a matter of personal preference if you want to have this on or off, maybe less. Maybe you want to expose this in the HDA, but for now we'll just leave it like this. I'm gonna pull all of this that's related with the scattering. I'm gonna pull it to the side. And that's it. So now we have our scattering system adapted to our terrain, our asset, and we can move on to the next lesson.